This is a short video intended to demonstrate how to use Rhino3D to visualize the V-lines computed with GHS stability software. V-lines are meant to represent the highest water level possible inside a watertight compartment after flooding. I don't intend here to go too much into the detail of the regulatory definition of V-lines, and hopefully this diagram will constitute a good graphical illustration. It is taken from the DDS 079 rules from the US Navy. Yet, V-lines are criteria we retrieve in many regulations, with possibly some variations on the requirements. In GHS, we have a geometry model available which I now load into the software. The same geometry is available in the Rhino environment. Let's remember that Rhino3D is capable of reading and writing GHS geometry files. In GHS, V-lines are computed thanks to a short script stored into a run file. Presented here. No need to detail the exact content of this script. I'll just mention that there is a calculation of a rollback angle. Its computation is a polynomial, derived directly from the DDS 079 regulations mentioned earlier. And then, the heart of the V-lines computation is a custom macro command. It is a sequence of GHS commands that will harvest the height of the water plane inside each compartment after it was eventually being flooded. Our macro command is being executed here 8 times, because our vessel geometry holds 8 watertight compartments. What is taking place inside this macro command is that we are messaging out into a text file some Rhino instructions. Line 74 here, for instance, creates a new Rhino layer where the newly created geometry will be stored. Next lines will provide XYZ coordinates to generate the actual V-lines. And in fact these geometries are planes, so effectively may be called V-planes instead. Let's execute this script. It is pretty instantaneous, and produces a text file containing the V-lines coordinates for the 8 watertight compartments. The text file content is then simply copy-pasted into the Rhino command line. V-planes are then appearing graphically, and the newly created layers will also show up in Rhino's layer manager, again 1 layer per compartment. By the way, the color of each layer is actually random. This is achieved thanks to GHS featuring a random variable, allowing to compose random RGB coloring for each one of those layers. The finished products are native Rhino surfaces. So your usual Rhino toolset is available for whichever next editing steps. For example, here, employing some Rhino cutting planes to isolate and focus on one compartment in particular. I hope this content was of interest to you. Thank you for your attention.